Hi guys, welcome back to my channel. In today's video, I want to share with you factoring the greatest common monomial factor. Let's get started. Right, let's take the first example. So the polynomial is 12m squared n to the 4th p cubed plus 48m cubed n squared p to the fifth minus 12m to the fifth n cubed p squared. So first, find the GCF of this polynomial. Okay, so what is the GCF of the numerical coefficients? So we have 12, 48, and another 12. So the GCF is 12. Now, how about on the literal coefficient? So for the variable m, so we have here m squared, m cubed, m to the fifth. Again, get the least exponent of the variable. So in this case, that is m squared. Next, for the variable n, here we have n to the 4th, n squared, n cubed. So that is n raised to the 2nd power. And then for the variable p, so we have here p cubed, p to the fifth, and p squared. So get p raised to the 2nd power. Then, to get the other factor, divide each term of the polynomial by the GCF. So the first term, which is 12m squared n to the 4th p cubed, divided by the GCF, which is 12m squared n squared p squared. So, 12 divided by 12 is 1, m squared divided by m squared is 1, and then n to the 4th divided by n squared. So, that is n squared. So again, in dividing power with the same base, subtract their exponents. Next, p cubed divided by p squared is p. Next, second term, which is 48m cubed n squared p to the 5th power divided by 12m squared n squared p squared. So, what is 48 divided by 12? So it's 4. Then m cubed divided by m squared is m. Then n squared divided by n squared is 1. And then p to the 5th divided by p squared is p raised to the 3rd power. And then the last term, which is negative 12m to the 5th n cubed p squared. So divided by 12 m squared n squared p squared. So negative 12 divided by 12 is negative 1. So m to the 5th. So m to the 5th divided by m squared is m cubed. And then n cubed divided by n squared is n. And then p squared divided by p squared, which is equal to 1. And then express the GCF and the quotients here as the product. So we have 12m squared n squared p squared times the quantity of n squared p plus 4m p cubed minus m cubed n. Now, to check if the factors are correct, so get the product of these factors. So let's check. So 12m squared n squared p squared times n squared p is equal to 12m squared n to the 4th p cubed. The next, 12m squared n squared p squared times 4m p cubed. So that is, so 12 times 4 is 48 m cubed n squared p raised to the 5th power. Then last, so 12m squared n squared p squared times negative m cubed n is equal to, that one is equal to 12 m raised to the 5th power n cubed p squared. So this one is similar to the given polynomial. So therefore, the factors are 12 m squared n squared p squared and the quantity of n squared p plus 4 m p cubed minus m cubed n. Let's have another example. This one looks a little odd in comparison with the first example. However, it works the same way. Now, look at this polynomial. This polynomial has two terms, the first term and the second term. Why? We considered this like the quantity of x minus 3 as monomial. It's because it's enclosed by parentheses. So, same true with the quantity of x plus 4 is also monomial, and also the quantity of 2x plus 5. So, the same thing, first identify the GCF of this polynomial. So, the GCF, since x minus 3 is common to both, so the GCF is x minus 3. Okay, the next, divide each term of the polynomial by the GCF. So we have x minus 3 times the quantity of x plus 4 divided by the quantity of x minus 3. So cancel x minus 3, that one becomes 1 over 1. And then multiply all remaining factors. So 1 times x plus 4 is x plus 4 over 1, or simply x plus 4. Next, the second term is negative times the quantity of x minus 3 times the quantity of 2x plus 5. Again, divided by the GCF, which is x minus 3. So x minus 3 divided by x minus 3, so cancel, that one becomes 1 over 1. So, negative 1 times the quantity of 2x plus 5 is equal to negative times the quantity of 2x plus 5. And then, express the GCF and the quotients obtained here as a product. So we have x minus 3 times the quantity of x plus 4 minus the quantity of 2x plus 5. And then simplify the expression inside the brackets by combining similar terms. So, quantity of x minus 3. So, we need to remove the parentheses here. Okay? So, by using the distributive property, so the numerical coefficient of x plus 4, since x plus 4 is a monomial, the numerical coefficient is 1. Then, distribute 1 to x plus 4. So 1 times x is x, 1 times 4 is positive 4. Same true with here. So negative 1 times 2x is negative 2x. Negative 1 times positive 5 is negative 5. Again, combine similar terms here. So copy the GCF, which is x minus 3, and then combine x and negative 2x. So that one is negative x. And then 4 minus 5 is negative 1. So therefore, these are the factors. Okay, let's have another example. So it's 5a to the power of 2 times the quantity of x plus y, close quantity raised to the power of 3 minus 38 times the quantity of x plus y raised to the power of 2. So again, identify the GCF of this polynomial. So, the GCF of 5 and 30 is 5. For the variable a, so we have here a squared and then a, so get the smaller exponent of a, so which is 1. And then for the quantity of x plus y, so here it's the power is 3, and on the second term the power is 2, so therefore get the quantity of x plus y raised to the second power. So this is the GCF now. So again, divide each term of the polynomial by the GCF. So 5a squared times the quantity of x plus y raised to the power of 3 divided by the GCF, which is 5a, times the square of x plus y. So cancel. 5 divided by 5 is 1. A squared divided by a is a. Then the quantity of x plus y raised to the third power divided by x plus y to the second power. So just simply subtract their exponents. So 3 minus 2, which is 1. So that is the quantity of x plus y. Next, the second term is negative 30a times the square of x plus y divided by 5a times x plus y to be squared. So, negative 30 divided by 5 is negative 6. A divided by a is 1. And then the square of x plus y divided by the square of x plus y is also 1. Or simply, the quotient here is negative 6. Again, express the GCF and the quotients here as a product. So that is 5a times the square of x plus y times the quantity of a times x plus y minus 6. Again, remove the brackets by simplifying the expression inside of this bracket. So that is 5a times the square of x plus y, and then use the distributive property. So a times x is ax, a times y is ay, and then minus 6. Okay, let's have the fourth example. So which is 15 times x minus y minus 20 times y minus x. Now, is x minus y similar to y minus x? Definitely no. What we're gonna do now is to factor out the negative 1 for both x minus y and y minus x. Okay, so factor out negative 1, so x minus y. Factor out negative 1 and then divide. So x divided by negative 1 is negative x. Negative y divided by negative 1 is positive y. Or that one can be expressed as negative 1 times the quantity of y minus x, which is similar to this. Next, for y minus x, again, factor out negative 1 and then divide. So y divided by negative 1 is negative y. Negative x divided by negative 1 is positive x. Or, that is negative 1 times x minus y, which is similar to that. Okay. In this case, the polynomial has two sets of factors. Let's have the first one. So, express y minus x into x minus y. So, that is 15 times x minus y minus 20, where y minus x is equal to negative 1 times x minus y. And then simplify. So 15 times x minus y, and then negative 20 times negative 1 is positive 20 times x minus y. Now, look at these two terms. These two terms are similar, so therefore, we could simply add their numerical coefficients. So that is 15 plus 20 is 35, and then copy their common literal coefficients, which is x minus y. So, this is one of the set of factors. Let's take the other factor. So, change x minus y in terms of y minus x. So 15, where x minus y can be expressed into negative 1 times y minus x. And then minus 20 times y minus x. 15 times negative 1 is negative 15 times the quantity of y minus x minus 20 times y minus x. Again, these two terms are similar, so add negative 15 and negative 20, which is equal to negative 35, and then copy their common literal coefficients, which is y minus x. So therefore, the factors are 35 times x minus y, or negative 35 times the quantity of y minus x. Alright, let's have the fifth example. So, which is 25, a raised to the power of 3m plus 2, b raised to the power of 4n plus 1, plus 15, a raised to the power of m minus 1, b raised to 2n plus 3, and then assume that all exponents are whole numbers. So, what do you think is the GCF of this polynomial? So, the GCF of 25 and 15 is 5. And then what about on the literal coefficients? So again, a raised to the power of 3m plus 2 can be expressed as a raised to the power of 3m times a raised to the second power. And then b raised to the power of 4n plus 1 can be expressed as b raised to the power of 4n times b raised to the first power. And for a raised to the power of m minus 1 can be expressed as a raised to the power of m times a raised to the negative 1. And then for b raised to the power of 2n plus 3 can be expressed as b raised to the power of 2n times b raised to the third power. So the GCF for the literal coefficient, so in here, so a, so again, get the least exponent. So 3m and m, so a raised to m, and then 2 and negative 1, a raised to negative 1. Or that is a raised to the power of m minus 1. And then, for in here, so b raised to the power of 2n times b, or simply b raised to 2n plus 1. So let's divide. So the GCF now, what is the GCF? So the GCF is 5 times the quantity of a raised to the power of m minus 1 times b raised to the power of 2n plus 1. So divide each term by the GCF. So the first term is 25, a raised to the power of 3m times a raised to the second power times b to the power of 4n times b to the power of 1 divided by 5, a raised to the power of m minus a raised to negative 1 times b raised to 2n times b. Okay, so 25 divided by 5, so this one becomes 5 and that one is 5. So 5. A raised to 3m divided by m, so that is a raised to the power of 2m. Then a squared divided by a raised to negative 1, that is a raised to 3. So that is a squared divided by a raised to negative 1. So again, dividing power with the same base, subtract their exponents. So that is a to the power of 2 minus negative 1, or that is 2. Then negative times negative is positive 1. So that's why it's a raised to the third power. Moving on. Then b raised to 4n divided by b raised to 2n, that is b raised to 2n. And then b divided by b is 1. Okay? Or that one is 5a raised to the power of 2m plus 3 times b raised to the power of 2n. The next, second term, 15 a raised to the power of m times a to the power of negative 1 times b to the power of 2n times b to the third power divided by 5 a raised to the m times a raised to the negative 1 times b raised to 2n times b. Okay, so 15 divided by 5 is 3. Then a to the power of m divided by a to the power of m is 1. Then a raised to negative 1 divided by a raised to negative 1 is also 1. B to the power of 2n divided by b raised to the power of 2n is 1. And b cubed divided by b, that is b to the power of 2. So therefore, the factors are, of course, the GCF. So that is 5a to the power of m minus 1, b to the power of 2n plus 1, times the quantity of 5a raised to the power of 2m plus 3, b to the power of 2n plus 3b squared.